adding and subtracting rational expressions. Our objective is to add and subtract rational expressions with like denominators, as well as add and subtract rational expressions with unlike denominators. Who uses this? Kayakers use rational expressions to figure out travel time for different river trips. Let's start with adding rational expressions with like denominators. If a, b, and c represent polynomials and c is not 0, then if you have a over c plus b over c, that's going to be equivalent to a plus b over c. Let's practice. So this first example, we have 3b over b squared plus 5b over b squared. Since our denominators are the same, we can simply add our numerators. So we have 3b and 5b. When we add them together, we end up with 8b. Our denominator, just like when we added fractions back in pre-algebra, when you add fractions, your denominator stays the same. So we just have b squared. So now we can simplify. We can reduce this and have 8 over b. Let's try another one. This one's a little bit more complicated. So for this one, you want to combine like terms in the numerator. So x squared doesn't have anything in common, so we're going to just write that one down. Our minus 8x and our positive 2x, they are like terms, so we can combine them to get negative 6x. And then we have a plus 8, and there's nothing else with that as well. So plus 8, and all of that goes over our common denominator of x minus 4. We can simplify this by factoring our numerator. So if we factor our numerator, we end up with two numbers that multiply to give us 8, but when we add them, we get negative 6. So x minus 2 and x minus 4. And notice how on the top and the bottom we can cross something out. So we're only left with an x minus 2. Take a moment, pause the video, and try this next one on your own. When you return to the video, the answer will be revealed below. And there you have it. So, as a good rule of thumb, step 1, check for common denominators. You need to make sure that that is the case before you add or subtract. Step 2, combine like terms in the numerator. And then step 3, simplify if possible. This may mean you have to factor, or you could just simply reduce. Let's step it up a notch. So now we're going to subtract. It may be helpful to keep in mind that this whole quantity is together. Same with this one. This minus sign makes it so that you have to do an extra step. Now you know how when you had an addition symbol, you would just simply combine like terms. But if you think back to when we were subtracting polynomials, you had to distribute that minus sign. The same thing applies here. So we would have 3m minus 6 as that first quantity minus this negative m plus 2. And all of that is going to be over our m squared plus m minus 6. So we can distribute that minus sign and then combine like terms. So when we do so, our denominator is going to stay the same. And now we have 3m plus m, so that gives us 4m. And then we have negative 6 minus 2, so minus 8. And now we're on step 3. Can we simplify this any further? In this case, yes. So let's start by factoring out a 4 in our numerator, leaving us with m minus 2. And then if we factor our trinomial down here, we end up with m and m. And we need two numbers that multiply to give us negative 6, but when we add them, we get a positive 1. So, plus 3 and minus 2. Hey look, we can cross off these m minus 2's. So now we're left with 4 over m plus 3. Take a moment, pause the video, and try this next one on your own. When you return to the video, the answer will be revealed below. And there you have it. So now let's look at finding the least common multiple, since that's going to help us if we don't have common denominators like we've had in the past few problems. So what would be the least common multiple of 24a to the third and 4a? Well, let's write the prime factorization of each expression. So 24a to the third would be 2 times 2 times 2 times 3 times a times a times a. And 4a would be 2 times 2 times a. So we look at the ones that we have in common here, and that gives us our least common multiple. In this case, if we combine it all together, we end up with 24a to the third. Let's try one that's a little bit trickier. If it helps, think of the least common multiple as what is the smallest number that both 24a to the third and 4a can go into? Or in this next example, what's the smallest value that 2d squared plus 10d plus 12 and d squared plus 7d plus 12 can go into? We want to make sure it can go into both here. So let's start by factoring. First one, we're going to factor out a 2, leaving us with d squared plus 5d plus 6. And then we can factor our trinomial, and we end up with a 2 outside still, and we end up with d plus 3 and d plus 2. So that's our first term. So now let's look at our next one. So we have d squared plus 7d plus 12. So if we factor this, we want two numbers that multiply to give us 12, but add to give us 7. So that's going to be 3 and 4. So we have d plus 3 and d plus 4. So if we look, they don't both share a 2, so we do need a 2 here. So that way it takes care of that one. They share a d plus 3, so we only have to write that one once. So basically, if they share it, you only got to write it once. If they don't, you need to include it because one of those values needs it for it to be a least common multiple of that one, or a multiple of that product. So we've got 2 times the quantity d plus 3 times the quantity d plus 2 times the quantity d plus 4. Take a moment, pause the video, and try these next two on your own. When you return to the video, the answer for both will be revealed. And there you have it. So now let's put this idea to good use. So we're going to add and subtract with unlike denominators now. So we're going to use the least common multiple to give us common denominators. So what's the smallest term that both 6x squared and 4x can go into? Well, the smallest term that both of them can go into is 12x squared. So our common denominator is going to be 12x squared. So just like when we were doing fractions, what times 6x squared is going to give us 12x squared? Well, in this case, a 2. So whatever we multiplied our denominator by, we needed to multiply our numerator by. So 3x times 2 gives us 6x. And now for our 4x, 4x times 3x is what gives us 12x squared. So whatever we do to our denominator, we must do to our numerator. So 2x times 3x is 6x squared. So now we simplify. So we've got ourselves a 6x squared plus 6x over 12x squared. And we want to factor so that way we can simplify this into its simplest form. So we can factor out a 6x, And that leaves us with x plus 1. And now we can reduce our 6x and our 12x squared. So our 6x would go away. And our 12x squared on the bottom would become a 2, and then simply an x. So we end up with x plus 1 over x times 2. Now, you can't cross off the x and the 2x here because there's a plus sign in between. Keep in mind, you can only cross these out when they're being multiplied. So like the 6x was being multiplied to the x plus 1, and the 2 is being multiplied to the x. So therefore, we were able to reduce. Here, it's separated by a plus or a minus, so we can't. So that is your final answer. All right, take a moment, pause the video, and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. Let's try another one. Take a moment, pause the video, and try this one on your own. When you return to the video, the answer will be revealed. And there you have it. So now let's try a recreation application. Katie wants to find out how long it will take to kayak 1 mile up a river and return to her starting point. Katie's average paddling rate is 4 times the speed of the river's current. Write and simplify an expression for the time it will take Katie to kayak the round trip in terms of the rate of the river's current. Write expressions for the distances and rates in the problem. The distance in both directions is 1 mile. And we're going to use x. So we're going to let 4x represent Katie's paddling rate. So when we do this, we're going to end up with Katie's rate against the current is going to be 4x minus x, or we can simplify that to 3x. And then Katie's rate with the current is 4x plus x, or 5x. So now we can use that in our table below. So we have the direction upstream, or against the current. It's still 1 mile, but our rate is going to be 3x. Downstream with the current, that's going to be the 5x. So now we can deal with our time. Time equals distance divided by rate. So we end up with 1 divided by 3x and 1 divided by 5x. We can continue this. So if the rate of the river is 2 miles per hour, how long will it take Katie to kayak round trip? So we would substitute 2 in. So we have 8 over 15 times 2, which is going to equal 4 over 15. So it will take Katie 4/15 of an hour, or 16 minutes, to kayak the round trip. And that ends our video lesson on adding and subtracting rational expressions.